Hey guys, welcome back to the second part of my gas laws video. In the last video, I believe I covered Boyle's law. I know it's been a while. I've been meaning to make the second part of this video, but I have been really busy since then. I've been studying for this test, but now I just finished studying actually. And if you can tell, there's a difference in my voice. I'm currently sick right now, and I'm very tired since I've had a long day, but that's okay. I'm going to make this video because it'll be fun. But I also realized that I didn't finish some of the slides from the Boyle's Law video, so we'll finish that as well, and then we'll move on to Charles's Law. So, okay, so here we have Boyle's Laws continued. What I didn't mention in the last video is what happens when um between the relationships of pressure and volume. So when pressure is doubled, volume is 1/2 as great as it was. When pressure is 1/3 as great, volume is 3 times as great. And when pressure is 4 times greater, volume is 1/4 as much as it was. And here, if you look in this picture, I have a piston with would be our normal pressure, normal volume. You see the gas particles. And if you look at this piston, the piston is applying 2 times as much pressure, and it creates 1/2 as much. It creates 1/2 as much volume, so you can still have the same amount as gas particles in here. Okay, now that we've got that done, it's time to move on to Charles's law. So Charles's law states the relationship between volume and the Kelvin temperature at constant pressure. So volume and Kelvin temperature are directly proportional at constant pressure. As for example, as temperature goes up, volume goes up, and as temperature goes down, volume goes down. And here's the graph that you would see. It's a direct relationship, directly proportional. As pressure goes up, temperature goes up, direct. And here's the formula. V1 over T1 equals V2 over T2. Okay, so now we're going to go on to our questions. Okay, so here we have a sample of nitrogen occupies a volume of 250 milliliters at 25 degrees Celsius. What volume will occupy at 95 degrees Celsius? Okay, so you obviously want your scientific calculator on you. Remember, you can't use graphing calculators on the regions, so make sure you have a scientific calculator. But okay, so first things first, we want to identify our values. So we have, this would be volume 1. This would be temperature 1. This would be temperature 2. So we're looking for volume 2. And also we want to remember that when we do these problems, never use Celsius degrees, always convert into Kelvin. And by doing that, you would want to take your Celsius, add 273, and you get your Kelvin temperature. Okay, so I have the formula set up already. V1 over T1 equals V2 over T2. So if we take this and we would put I'm going to write this in a different color. So we first would have our 250 milliliters over, and 25 plus 273 is 298 Kelvin equals 95 plus 273 is 368 Kelvin. Looking for, why did I do that? Wrong variable. Okay, so when we are doing these problems, instead of multiplying straight across, we want to do cross multiplying. So we'd multiply, that was very bad. We would multiply these values and these values. So when we get to 250, multiply it with 368, we would get 92,000 equals 298 K. I mean, not K, V2. I'm really tired, guys. I'm so sorry. And then we want to divide this to get the variable on one side, just like you're solving for x in algebra. So 298, that was, my handwriting is very sloppy on the computer. So divide this. Your volume 2 would be, and we have 3 significant figures in this. So we want to round it to 3 significant figures, and we would get 309. So this is the first problem. And now we will move on to the second one. Hydrogen gas was cooled from 150 degrees Celsius to 50 degrees Celsius. Its new volume is 75 milliliters. What was the original volume? Okay, so first we want to identify our values. So we got, okay, yeah, I want that. So this is we have a change in temperature. So it's from 150. So that would mean this is our initial temperature, or temperature 1. This would be our second temperature. So again, we're looking for, it also says, this is very important, the new volume, 75 milliliters. So that means our volume 2 is 75. So we're looking for the original volume, V1. So I will solve this, and I want you to try to solve this before you look at the answer to this and what I get. So pause this, and then I'll write my setup. Okay, so this is my setup, and now we can cross multiply these two and these two, and what we'd get is 323 V1 equals 31,725, I think. Let me just look at my calculator. Yeah. Then we divide that both by 323, which we would end up with, after rounding to significant figures, 98.2. milliliters. Yeah, another thing, I didn't do the unit on this one, but it is very important to make sure you always add the units in your answers. That is something I need to work on as well. Anyways, that is all for Charles's law. Charles's law. I hope this helped you, and I will see you in the next video, which will be Gay-Lussac. Thank you for watching.